Hi everyone. So our paper is about counting graph colorings. Let us first define what a graph coloring is, more precisely a list queue coloring. We're given a graph, and for every vertex we have a list of colors, and we want to color each vertex such that it has no adjacent vertex of the same color, and that for every vertex we are only allowed to use colors from its list. So for example, this is a valid coloring of this graph. For example, for this vertex, we colored it in an allowed color green, and it has no adjacent green vertices. And similarly for all other vertices, the same is true. Another notion that we will need is the notion of cutwidth. A graph has cutwidth k if we can order its vertices such that wherever we cut this sequence, we will cut at most k edges. So for example, for this ordering and this cut, we are cutting these three red edges. So what did we do? We were looking at list colorings which use Q colors. We were counting them modulo some prime p, and we were parameterizing this problem by cutwidth. So what are our results? We got a lower bound, an upper bound, and what is very surprising is that both of them depend on whether p divides q minus 1, so whether this prime model of which we are working divides the number of colors minus 1. So how did we do this? The key idea is to use the color compatibility matrix, which is a matrix which tells us whether two colorings of parts of a graph are compatible. For example, if our graph is just this edge UV, we can see that all colorings of UMV are compatible unless we color UMV the same color, for example, red, then this matrix has entry 0, otherwise it has entry 1. If you want to hear more about our project, our paper, then join us on the 15th of March on Tuesday in session 1A at 10 o'clock.